Section 1.6 is entitled Function Operation and Composition of Functions. So the first thing that we're going to look at in this diagram is something that is probably going to seem like it's the obvious thing to do. And basically what they're saying on the first one, f and g are two functions with intersecting domains. For all x values in the intersection, the sum, product, difference, and quotient of f and g are new functions defined as follows. So what they're saying is that if you add the two functions here, all you're going to do is add their component parts. Same thing with the difference. If you want to subtract two functions, f minus g, you're going to subtract the two component parts. For the product, you're going to multiply component parts, and then for the quotient, you're going to divide component parts. The important thing to remember when dividing is that you need to make sure that g of x is never 0, because you cannot divide by 0. And so what we're going to go ahead and do is we're going to go ahead and look at a few examples. And if you look at this example 1, it says given f of x equals x squared plus 4x, g of x equals the square root of x plus 2, and h of x equals 3x minus 5. We're going to find each function and its domain. So what I need to do, or what I'm going to go ahead and do, is I'm going to go ahead and look at the f of x function. Okay, I want you to tell me what is the domain of the f of x function. And if you're wondering how you find domain, remember you can graph that. That would be one option, and you can see what x values works. Or you can see, look at the original problem and see, is there any values that I can't get? So what can you tell me about the domain of f of x? Well, what can you tell me about the graph of f of x? What does it look like? It looks like a parabola that opens up. Okay, it's x squared, positive x squared, it opens up. So are there any values that I can plug in here that won't work? No. No. So the domain here we know is negative infinity to positive infinity. I can plug every number in and get a number out every time.
How do you know it's a parabola?
Because it's an x squared graph. Something that you need to know, juniors, you are going to have an identification quiz either tomorrow or Monday where you're going to have to identify the parent functions. There are 8 of them. I will have a picture of the graph and you're going to have to identify, is that a constant? I will not have a word list as well. So you're going to have to know what a cubic function looks like, quadratic, identity, rational.
Can you write it right hand?
So, and that is no notes.
What are you talking about? What grade functions?
They are from section 1.5 that we went over. You're going to have to identify them. I talked about that earlier.
Yesterday when we were here?
No, 2 days ago. And I said you're going to have to identify those. Yes, probably. Okay. So let's go ahead and look at the domain of g of x. G of x equals the square root of x plus 2. So what is the domain of that? Once again, if you're struggling, you could graph that. Look at the graph. Tell me what the graph looks like.
It would be like one of those curved.
One of those curved things, because that's what the square root of x looks like. So it does look like one of those curved things. What can you tell me about that curved thing?
Starts at 0.
That's what the normal one starts at. What does that one start at? G of x.
+2, so you go to the left 2.
Go to the left 2, very good. So the domain then is -2 to infinity, and remember I can plug -2 in. Okay, h of x. What can you tell me about h of x? What's that a graph of? A line. Line with slope what? 3, y-intercept? -5. So this one, since it's a line, it will be negative infinity to positive infinity. So by doing that, we've made our job much easier, especially on the following problems. So the first one says f plus g of x. So basically what that means from our little diagram is that we're going to do this. We're going to take whatever f of x is, and in this case f of x is x squared plus 4x. And I'm going to add that to g of x. G of x equals root x plus 2. So that's fairly easy, right? That's part of your answer. The second part of your answer is now finding the domain of the new function. So what the domain is the intersection of these two. So in this case, it's the intersection of f of x is domain, and g of x. Intersection means what's in common with both. So if I compare these two, what is in common with both? Negative 2 to infinity. So that is my domain. But see, it's a lot easier to start by writing them down like I did, and then now you can just look and instantly see what your domain is going to be. So let's look at another problem. This one is the exact same problem, except for this one is f of x, or f minus h of x. So from that first diagram, what that means is f of x minus h of x. So I just need to plug in. I know that f of x is x squared plus 4x minus h of x, and I know h of x is 3x minus 5. You do need to simplify this before we go to your answer. Okay, so to simplify it, I'm going to distribute the negative, good. And I get x squared plus
1x.
x plus 5. Okay, domain is the intersection of those two. So if you remember from the first page, what was the domain of f of x? Negative infinity to positive infinity. What was h of x? Negative infinity to infinity. So what's the domain of this one going to be? Negative infinity to infinity. So it's where the two intersect, where they're in common. Okay. Alrighty, let's look at another one. This one is times. So all we're going to do is times the two. So I've got x squared plus 4x. And I'm going to take that times 3x minus 5. How do you multiply those together? How do you multiply them? FOIL. That's all you do. Okay, so far we really haven't done anything overly difficult. The domain does kind of throw a wrench into things. It makes things a little bit harder. So I get 3x cubed minus 5x squared plus 12x squared minus 20x. So now what I need to do is add like terms. And what do you get? 3x cubed minus 20x. There you go. And the domain here is negative infinity to where? Positive infinity. Good. So far so good. It's not too bad. Okay, I think we've got one more to look at. Let me double check. Yep, we've got h divided by f. Okay, so we have h of x over f of x. So first of all, h of x is 3x minus 5. F of x is x squared plus 4x. So can you simplify that at all?
Yes. Could be on top of the negative x.
Or bottom would just be x.
Yeah, whatever.
I don't think you can simplify that at all. Okay.
Why?
So there's nothing in common with all the terms that you can take out. So now this is where the problem is. We think the domain should be negative infinity to positive infinity. But there's one problem. What's the problem?
We need the domain.
Yeah, we need the domain. But it's not negative infinity to positive infinity. Can somebody tell me why?
Because it's divided by?
Yeah, this can equal 0. And so I need to find where can that equal 0, because remember you can't divide by 0. If you remember on that first page, I said that g of x in the bottom can't equal 0. So what we need to do is we need to go ahead and solve that. And we need to find where does x squared plus 4x equal 0. So I notice each of these has an x, right? So let's take an x out. If I take an x out, what do I get? X plus 4. So notice here I have two possibilities. What are my two possibilities going to be? 0 and negative 4. So those are the two values that make the denominator 0. Okay, so there are two ways I can write the domain. I could write it using interval notation. Interval notation would be the following. Negative infinity to where? Negative 4. Then negative 4 to where? Negative 4 to where? 0. And then 0 to infinity. That's one way. Or you could write this, x such that x is an element of the reals, and x cannot equal 0, x cannot equal negative 4. So either of those is acceptable. I don't care which one. You can write it either way. It's kind of whatever makes sense to you. So we're going to move on to another example, but I think probably I might be running close on time, so I'm going to go ahead and stop and restart the video.